everyone and welcome back to R&M Lab GH. I needed a custom keypad with symbols and special characters to speed up my programming in the Arduino IDE. I looked around but nothing met my specific requirements. So I decided to build it myself. I thought I'd make a video to share this project, a custom keypad for every need and truly versatile. Just by tweaking the code, you can get any special character, automatic strings or commands. This one is tailored to my needs, but I'm leaving the source file in the description. This way, anyone can build their own personalized supplemental keypad. The interesting part is that the communication between the PC and the keypad happens via Bluetooth. As you've seen, we're starting from the base to build the enclosure that will house our custom keypad. I decided to build the enclosure for my keypad using reclaimed wood profiles. I love having wooden objects in my lab, a blend of electronics and nature. I'll show you the steps I took to create the structure, which also serves as a stand for two 4x4 membrane keepers, the classic modules we've already seen in other Arduino projects. These keypads are perfect for this project. Since I wanted a complete set of special symbols, I did the math, and with two membrane keypads I have 32 keys available. This allows me to cover everything I need to speed up my work on my projects, programming in the Arduino IDE, and all my other tasks on the PC. The enclosure is finished. I gave it a 45-degree incline to make it comfortable to use next to the monitor. I have also positioned the membrane keypads to measure out the wiring. Now I'm moving on to the circuit draft. As always with my projects, I start with a prototype on a breadboard using jumper wires. You've never seen this step in my videos before. Bit by bit, I'm revealing my workflow and everything that goes into my projects. I map out all the connections on a sheet of paper. This way, when I build the board, all the pins will be in the right place. This is the system I use. Now, let's move on to building the electronic circuit. For this project, I use an ESP32 two 4x4 membrane keypads and male and female header strips to house the module and the keypads. I also used a perf board and jumper wires for the connections. The wiring is very straightforward, however, I'll leave the schematic in the description. As you'll see in the video, the connections are simple, the code does all the heavy lifting. The only key detail in this project is taking precise measurements for the keypad connections on the male headers and positioning the ESP32 correctly, ensuring the entire assembly is convenient, accessible, and clean. The electronic part is finished. Now I'm moving on to placing the circuitry inside the enclosure I built earlier. I'm attaching 2 small pieces of wood to create guides for the circuit board. This allows it to slide into the enclosure, making it easy to remove for any future modifications or repairs. Using hot glue, I'm securing the keypad ribbon cables to the body of the enclosure so they stay in place and don't risk breaking. On the bottom of the case, again with hot glue, I'm adding 4 silicone washers. This prevents the keypad from sliding on the workbench and ensures it's easy to use. Finally, I'm securing the board to the enclosure with a screw so that everything stays rock solid. Now, I'm moving on to finishing the wooden enclosure to give it a unique look and some protection. As you've seen in my previous videos, I treat the wood with soy sauce. It might sound strange, but it's an excellent product. It creates a very distinctive effect, protects the wood, and is safe to use indoors. This is what truly sets it apart. Plus, it's much more affordable than traditional varnishes, stains, or harsh chemical products. While the soy sauce was drying, I felt like something was missing. I decided to add a touch of light by placing some LEDs under the base. I remembered a trick I used a while ago to distribute light even using only 2 components. I took a regular drinking straw, cut it to the right size, and inserted a blue LED into each end. With just 2 lights, the problem was solved. As you'll see in the video, I secured everything with hot glue, soldered the wires, and added a male header piece to the board. I made 2 connections, one to GND and the other to the 3.3 volt pin of the ESP32. Now that everything is complete, there's one last thing to finish the look of my keypad. I decided to place white adhesive labels on the keys and draw the specific symbols I've chosen for each function. This makes it truly unique, handcrafted, and comfortable to use. I drew the symbols with a black marker. They aren't perfect, and that's exactly what I like, that distinct, artisanal touch. After placing the labels and drawing the symbols and applying transparent adhesive tape to protect them, it turns them into glossy stickers, a quick and budget-friendly trick. I could have printed the symbols, but honestly, I like it this way, a raw look with a high-tech art. Now let's move to the computer to upload the code. I'm connecting the USB cable to the ESP32, selecting the correct board and communication port, and starting the upload. You can find the source code and the schematic in the description. I want to clarify one thing: this code is optimized for Linux. It may not work properly on Windows without some adjustments. If you plan to replicate this project and have trouble with the code for your operating system, let me know in the comments. I'll be happy to help. After the upload is complete, we just need to configure the Bluetooth to pair the ESP with the PC, and then we can finally test the keypad. Now that the Bluetooth configuration is done, we can test the keypad. With a simple click, we have parentheses, curly brackets, and square brackets, the percent sign, the plus sign, the slash, quotes, and the semicolon. We also have the period, the @ sign, the ampersand, the question mark, the minus sign, the colon, and the comma. There's the hyphen, the underscore, the euro and dollar symbols, the exclamation point, and the multiplication sign. We even have right and left arrows, copy and paste functions, the asterisk, the hash, the equal sign, and the division sign. Everything is very simple and fast, just one click. I hope you found this video helpful and that you enjoyed the project. If you liked it, please leave a comment, subscribe to the channel, and hit the notification bell so you don't miss any future experiments. Thank you for your company, and as always, I'll see you in the next video. Bye!